Um,
No,
Good
no,
evening.
yeah,
No,
yeah. Let me start here.
sorry.
Pros and cons of coal, oil, natural gas. Part one. This is Cleveland Jones, Professor Cleveland Jones. This is the consultant advisor, Paul Taylor, and this is me. Uh, Let me start only as a context. Today we'll be discussing positive and negative points of each energy source, coal, oil, and natural gas. In part two, maybe next Tuesday, if you agree, of course, we will be comparing solar, wind, nuclear, maybe hydro, maybe hydrogen as a source. And the idea so today is to go to coal, oil, and natural gas. And Paul, the idea is to start with your presentation around 12 minutes or something like that. And just after we can start with Cleveland presentation. It's okay for you both?
Sure, that's very good for me. Thanks.
Perfect. So I will move your slides here.
Okay.
Paul, please start with you.
So if you move to the next slide, which is basically, I'm going to be talking today about the positive and negative aspects of these three energy sources. And the one thing you will notice throughout is the common recurrent theme of cost and infrastructure for all the three energy sources, as well as the environmental impact that they have. And if you go to the next slide, these are the positives and negatives that I've decided to talk about with regard to coal. Coal gets a very bad name in the media, but it's a very reliable and abundant resource, and it's been fueling modern Western society for a very long time. And I'm talking going back centuries because we've mined coal from the surface for a very, very long time. Although coal did reach its zenith with the advent of the steam engine and the Industrial Revolution. And today, coal remains one of the primary sources of energy and provides thousands, tens of thousands of jobs to hardworking coal miners around the world, whether it's in open cast mines or underground. It's also a very abundant resource. And according to data from the US Energy for Information and Administration, there are the demonstrated reserve base of coal is currently at 475 billion tons, with over 235 billion tons recoverable. And coal reserves can be found in over 70 countries around the world, and all of these reserves they are expected to outlast those of oil and gas together. Furthermore, many of the technologies and the national um, electricity grids they're already designed to use coal. So this means that the amount of capital investment needed to create new resources is also lower than with other alternative solutions such as renewable energy sources. The pro coal agencies say that this resource can be mined and burned with little environmental impact, especially considering the recent improvements in environmental responsibility and the arising clean coal technologies. For example, with CCS technology, harmful carbon dioxide can be captured and stored before it can reach the atmosphere. Coal can be made cleaner through a liquefaction process, which converts the resource into a material that burns cleaner and reduces emissions. I find this argument very difficult to defend because the onus then rests with the consumers and not with the mining companies. The consumers have to install the equipment to remove the carbon dioxide. And this is something that's going to prove to be exceptionally expensive, both politically and financially. We live in a difficult shareholder dependent world where profit margins are measured and the taking of environmental action is not seen as a financially efficient motive. Yes, it can be done, but there is a complete lack of motivation and less pressure comes from the government. Coal is also very cost effective, and the pro coal school will argue that it's the most affordable source of energy available to us. And one of the quotes I got was from the National Academies of Science, Engineering, and Medicine. Strangely enough, coal is the least expensive for its energy content. It's a major factor in the cost of electricity in the United States. Well, let's quickly look at the negatives. The advantages of coal are now being weighed against two significant disadvantages: the release of the carbon dioxide, which I mentioned earlier, into the atmosphere when it is burned, and the dangers posed by the extraction process. The vast majority of the global scientific community is now in agreement that the release of greenhouse gases such as carbon dioxide results from the burning of coal and other fossil fuels, thus warming the Earth's atmosphere and contributing to the global climate change. Coal-fired power plants are also the greatest contributor to mercury pollution. And a second issue, or a very important issue that I'd like to just mention, is how dangerous coal mining is. Whether it be open cast mining with those huge pieces of machinery, or whether it's underground. And I've worked underground, and the last coal seam I worked on was only 66 centimeters in thickness. So it is dangerous, and it comes with a huge cost of life, as well as environmentally. And those big open cast mines, they are a huge eyesore, but with proper government control and legislation, those open cast mines can be returned back to a natural, normal looking state, and sometimes better than what they were before. The next slide, please.
Paul, let me suggest that we start with Cleveland analysis for coal to concentrate all issues about coal. Do you
Sure.
accept that?
Yeah,
Great.
sure. That would be good.
Yeah,
Cleveland,
okay, Kavaya. This is fine because coal is one of the most talked about fossil fuels and energy sources that is being discussed, exactly because of what Paul said. You know, many very compelling advantages and very worrisome disadvantages. But I wanted to focus on the differences in coal as a resource in different settings. The first picture on the left here is the Wyoming, largest coal mine in the world there, Antelope Rochelle mine, I think it's called. It's almost 100 feet solid coal, good quality, low ash content, not a lot of problems in mining it. Basically, like Paul said, giant machines can dig it up very inexpensively. Yes, maybe there are hazards involved with mining, but certainly quite different, for example, than on the right side, where I was just telling you some years ago when I was at the University of the State of Rio de Janeiro in the geology department. I joined field trips with professors to take our students to visit various energy resources. And one of the places that we went was in the southern Brazil state of Santa Catarina, where they have coal mines, underground coal mines, which are obviously much more dangerous than above ground mines or open pit mines, and coal seams that are barely centimeters thick, very dirty, lots of ash and other impurities. So, nothing comparable to the coal seam in Wyoming. Even if we had just 20 centimeters of that 100 feet, that would be fantastic. But it's not even that. And yet they continue to mine it, at great dangers. And we've had problems in the past with miners and so on. And at very big, serious environmental impacts, because coal mining, you have all these areas around it where the industry has mined the coal looks like a moonscape, and restoring that area is just horribly expensive, difficult, and imperfect. So, this is all very strong contrast in what I consider a major energy resource in the world that has very different characteristics from one place to the other. If we can go to the other slide, I talk a little bit about these specific points, because you have to contrast, thick, clean, high quality coal seams in an open pit setting, which lends itself to much easier mining and less environmental problems, with the very thin seams, dirty coal, low quality, such low quality that it has to be mixed with other fuels in order to really get burned in a thermal coal plant that is mined in Brazil. But this is not to get down in Brazil. Many other countries have low quality coal also, and yet they mine it. And I think this all comes down to this realization. Energy security and the impact on the local economy from any kind of mining, because it provides jobs and so on, is often set against the economic viability of low-cost resources and the low environmental footprint of some of those resources. This is a trade-off that's very hard to work, because both of those are compelling depending on the situation. Politicians, of course, are very sensitive to economic impacts and population impacts, maybe less sensitive to environmental concerns. And of course, everybody is concerned about energy security. So, if you have some coal, you decide to mine it just to provide the country with some form of energy security. Those are very drastic differences, and unfortunately, the pros and the cons there are very clear and visible. It doesn't make the decisions any easier, but it's important to have that in mind, especially when decision makers have to consider these things in terms of local impacts, countrywide security impacts, environmental impacts, and so on.
That's great. We have
Cleveland.
please
Sorry,
go ahead.
can I just Cleveland? One of the things that we rarely remember is that the people, the consumers in the street, don't realize that there are different qualities of coal, ranging from lignite through to anthracite, and that quality of that coal will have a huge impact on the economics of mining the coal out of the ground.
Yes, I was saying before, unfortunately, we are very focused on the professionals in the industry, on decision makers who may not even, who may listen but not pay attention to what we say. And unfortunately, there's also a very important part of the public that we should be addressing, which is the consuming public. And they have to be informed so that they can make some informed decisions and pressure, for example, authorities to take the decisions that they favor. And this is all part of a democracy. The participation is influencing the politicians so that they will take decisions that are based on rational choices.
Yeah, we have two comments from Luis Carvalho. This is the first. My friends, one form of C. It's terrible. We need to spot this.
Which, like we said, coal is indeed, a horrible villain in that sense. Yes.
Yeah, and he is relating this Rio Grande do Sul state problems with rains. With this
again,
I'm not sure that's direct.
Well, but for example, if the public was better informed, maybe they would say, do we really have to go after coal resources that are so much lower quality, higher impact, higher cost than importing coal? Given that coal is available from many countries, it's not making this energy security that challenge. But it's something that the public has to be more aware of also.
But Cleveland, Paul, we are not able to replace coal at this time. Coal is
Uh,
so
ex-
let's see, present in
What
terms
what
of
do you,
electricity generation that we cannot substitute, replace
but
this.
but but
can
Cavani,
be
I think that the question is not substituting coal, but substituting types of coal, because many countries, including the U.S., even Russia, South Africa, and so on, can produce much more coal than they are producing now, of much higher quality, and substitute. For example, India has less quality coal, which they're burning and producing and burning, and just that substitution could afford a significant air quality improvement. I'm not even talking about CO2 emissions. I'm talking about SOx, NOx, all kinds of air pollution that harm people's health. That could be substituted. And so it's clear that one type of resource is not equivalent to the other. That's a basic.
That's the point. Yeah, Paul, please, your comment on this point.
well, professionals outside the mining industry are not going to know about coal quality. But the thing is, coal has been an important part of the whole cycle. In South Wales, in the United Kingdom, we had coal, we had lime, and therefore steelworks started operating. To get the coal out of the ground was hard labor done by children, women, and men. But then we had to transport that coal to the steelworks. And then so we saw the first commercial use of railroads. And those railroads used coal as an energy source. Now, those steelworks, especially the ones in Port Talbot, now owned by the Tata company from India, they are thinking of converting the furnaces in the steelworks to electric furnaces. And so coal, especially steam coal, which is perfect for steel making, is not going to be used. We don't mine coal anymore in the UK. It's a very small operation. Most of the coal comes from Poland and other places. But so those countries are going to suffer when major industrial units such as steelworks are going to convert.
Yeah.
There's the big impacts coming.
Yeah, there are more comments from Luis Carvalho about abandonment of coal, but it's in LinkedIn, so you can answer directly in LinkedIn. I prefer to go ahead with oil, if you agree.
Sure.
And you could start with Paul again, oil.
Okay, next slide, please.
Sure.
I've listed here the many positives and negatives of oil. I'm going to concentrate on three for oil. It's a mature technology. We've been exploring for oil, producing it, transporting it, refining it for a very long time. And from exploration through to delivery to the consumer, the complete cycle is very efficient and well understood. Rarely do you ever see gas stations, petrol stations, whatever you want to call them, running out of oil. The supply is always there. Same whether we're talking about oil-fired electricity generation. Anybody who uses oil on a grand scale as a consumable, the process, the cycle is very, very efficient and is almost uninterruptible. Yes, we've seen restrictions being applied and applied deliberately. For example, Russia against Europe, but it's still seen as a very reliable energy source. Oil has many derivatives, and I've mentioned one. And I found this on one of the websites in my research for this, and they talked about oil being used as for plastic production. I see that now as a negative, considering all the bad press about the amount of plastic and microplastics in the oceans and on the beaches and in the land. So is that a negative or is it a positive? There are many, many negatives associated with oil, and there's very little need to go into these in detail because we read about them every day in the newspaper. We read about them in our professional bulletins that we subscribe to. Yes, we all know about the air pollution that comes from the burning of oil, whether it be from power generation or in the vehicles that we use. Yes, we know that pollution is causing greenhouse gas emissions and contributing to global warming. Oil has been and will be used as a bargaining tool um, for the justification of conflict. But, when we looked at its dependency on other nations, we've seen oil being used as a bargaining tool. And even net exporting countries, they rely sometimes on importing oil. For example, they may want to sweeten their oil and increase the quality of their oil. They may want to produce a crude that's got a higher calorific value. Whatever the reason, there are dependencies, global dependencies. And then we've got the global oil market. The oil companies don't really have much say in that, but they are totally dependent on that market. Next slide. Well, I think at this point, maybe Cleveland should
Yeah,
talk.
good. Yeah, thank you, Paul. Cleveland, could
Yeah,
go on.
come on. Same thing. I wanted to point out contrast because oil is not the same all across the world in different types. And for example, as you know, I'm a big. My big focus is on the Brazilian pre-salt and the oil produced there, which is light, high quality oil. The lifting costs are, from $3 something to $5 something a barrel, unbelievably low. When I talk to some professionals in Houston, they say, "Oh no, Cleveland, you've got those numbers wrong. That can't be." Well, it's in the reports, the financial reports that Petrobras puts out. It would be in their interest to say it's higher. And, those are costs with and without FPSO costs involved. So either way, it's just very low. And if you compare that with even Saudi Arabia, whose numbers are totally unreliable, so it doesn't matter what Aramco says, but I am convinced that they're close to $10 a barrel, maybe higher. U.S. shale, of course, is very prolific, but lifting costs are $20, $30. Well, I put 20 to 20, but I mean 20 to 30, say. Some places more, of course. And it's still very economical, but I'm saying there's quite a big difference. And the same applies to environmental footprint, whereas the pre-salt oil is among the lowest environmental footprints of oil produced in the world. Petrobras was just awarded a 2023 OTC prize for its low environmental footprint in oil operations because of such low footprint. It is very easy to separate and contain CO2 emissions during production. Operations at FPSOs are more and more environmentally correct and so on. And you also have to contrast that with, say, Canadian oil sands, which, they can say a lot of things, but it's an environmental disaster. Venezuela, I was there. I saw, as far as the eye can see, just sea of dried oil on the surface of the land, as far as you can see every which direction. Heavy oil, tar all over. The same with marginal oil for many regions in the world, which is produced still at very high production costs, lifting costs or production costs, and extremely high environmental footprint, because many of these operations really don't have very high standards to begin with. So again, we fall into the same dichotomy that I discussed before. Countries may still produce oil that is relatively expensive and more polluting because of the advantages locally, because it provides some incentive for development and so on and jobs. and country-wise because it provides energy security. So they will produce it. Whereas, the decision based on economic viability of low-cost production or low environmental footprint would dictate that you produce oil in Middle East, Brazil, and a couple other places which are much less impactful and less costly to produce. But of course, those are not all the decisions that go into a decision to produce. Countries and companies have to take those into account. I would say that, yes, it is a difficult decision, maybe not as difficult as they make it out to be, because again, oil is pretty widely spread around the world, and many countries are able to supply it. So a smaller country to produce oil that's very expensive and polluting really doesn't justify it, because the savings from importing lower cost oil and passing on those savings to the populations that would have benefited from production may overcome that disadvantage. So again, it's a difficult decision, but I think that the more we understand how that resource has various nuances, the better we can make a decision. And just to point out one striking example, that Saudi Arabia imports, or until very recently, oil from Brazil, because Saudi Arabia has oil coming out of its pores, mostly good light oil. And until recently, Brazil was known for producing heavy oil. Nowadays, it's high quality light oil from pre-salt and so on. But Saudi Arabia needed our Brazilian heavy oil because they wanted to put asphalt all over the country, because it's a road situation that can't be supplied with light oil. So, these decisions sometimes go beyond cost or logistics.
Sure. I have 2 points for you both
Yeah.
to see your opinions. The first is that 20 or 30% of oil demand in the world is used in petrochemical products, based on refining oil products and sending to as feedstock to petrochemicals.
I know,
This is a
this is
very
your
huge
favorite
problem.
theme.
It's,
Yeah,
it's not simple to substitute this
yeah,
process yet.
very
This is
good.
the first point. Do you agree, Cleveland? And
Yeah,
Yeah, I at this point in time, it's not going to be easy. It's impossible to replace the oil,
Yeah.
and maybe that will become the main market for the oil as the renewables take over, if they do take over.
yeah. I think that the one point, the contrasting point that I would make here is that we've often talked about the petrochemical industry as a continuing demand for oil, and I agree. But the petrochemical industry produces products, plastics, and many other types of products whose demand can be substituted by other products. So it is not just on the supply side that we are tied. It's maybe also on the demand side, because as long as the world demands lots of plastic, increasingly so, China and India a couple of years behind China, and Africa a couple of years behind India, the demand will be there, but maybe that demand can be substituted with alternative products that are not plastic.
That's the point. But at this time, it's impossible to replace.
Impossible.
No problem. The
No,
second point, sorry,
Sorry,
Paul.
I was just going to say that there are plenty of byproducts, but there's one byproduct: lubricants. Even if you've got an electric vehicle, you still need lubricants.
Yeah.
What if the oil becomes so expensive or uneconomic to take out of the ground? What are we going to replace those lubricants with?
Yeah, that's one area where you're guaranteed demand. Yeah.
And the second point I would like to address for you both is the logistics applications for heavy trucks, for military tanks, for ships. At this time, we cannot replace oil.
They will be among the last conversions in the economy, maybe 20 years from now or something. All other uses will be before that. You're right. The heavy transportation is going to be much slower. The only thing that I would say may be a little different is in ships, because if we become more and more focused on LNG. LNG is supplying those same ships. Maybe it can also supply other ships on a very economical basis. That might make a dent. But again, we're looking at a long-term conversion.
Yeah, well, I was
we have
reading
a
I was reading an article a couple of weeks ago about a large not container ship, cargo ship that sailed around the world using only electrical energy and sails, mechanical sails. I don't know whether it was successful.
More than one
Technically or
experiment, Paul.
financially.
More
Sorry?
than one experiment now in three regions. I followed them. Yes, very obviously we're not at the commercial stage yet, but
No.
but that's technology. It'll take a couple of years. But it is clear that we're working, or the world is working, or someone is working. Technology is working on alternatives that will make a dent, even in that demand type.
Yeah,
I
but
mean,
it takes time.
at one point, I actually thought that we could go back to airships, hydrogen-filled airships, transporting large pieces of cargo around the world. But I don't think that is going to happen. That's a bit of a steampunk dream.
The comment is very, very direct comment from Mr. Carvalho.
Yeah, this especially precious resources for new generations and so on. This is a common theme that we have seen futurists talk about, because we're so focused on the next 5, 10, 15, 20, 30 years. But if we think of human civilization, not just 2,000 years since Christ, 5,000 years or 10,000 years since we started working with metals and so on, what is the coal era? It's a blip on the graph. What is the oil era? Even smaller blip. And all these alternative energies, they are a needle in the graph. So if we look forward, to the next 100 or 200 years, and I hope civilization will be around by then, we have to take this longer term view that all of these discussions are very short term. We talk about 30, 50 years as long term, but that's in terms of our lifetime. But in terms of human civilization, that is nothing.
Nothing.
Yeah.
No. Let's go to the third and last fuel, natural gas.
Okay.
Paul,
I had to be very careful. When I Googled a photograph of gas production, I kept getting all these or politically incorrect pictures of flaring. And so I chose this one. And so if you go to the next slide.
Paul, let me interrupt just for one thing. Later, I can share with you, we redid this picture because we saw so many errors and inconsistencies that we were just not satisfied. Some students and I sat together and say, hey, let's fix this and make it more realistic geologically and engineering-wise. But you're right.
There's so much wrong with this cross-section. But it was the only one I could find that didn't show flaring. If somebody was to ask what are the three main advantages of natural gas, they are price. And according to ourworldindata.org, natural gas is much less expensive than the other fossil fuels such as coal and oil. But other fossil fuels have many more harmful combustion products than natural gas. And if we burn natural gas under the perfect combustion circumstances, it gives off a very light blue flame, and there will be minimal to no harmful compounds being put into the atmosphere. Natural gas, it's one of the best energy sources to store and transport. It can be transported by international pipelines, very, very long distance ones as we've seen around the world, or in tankers in LNG form. So it's very, very easy to transport and store. But is it safer and easier to store than other fossil fuels? The natural gas community thinks it's true. But it's clear that natural gas is one of the best non-renewable sources of energy. So if we can go to the next slide, please.
Sure. 1 second.
Negatives for natural gas is that it's a gas. It's a flammable, explosive gas. So it is dangerous. It's dangerous to handle, and so being a combustible material which can explode, you can't cut costs. Some people have tried, and they have maybe they're not around anymore to see their mistake. So you need equipment that can handle this gas safely. And the installations, they have to be safe themselves. So, and a gas leak meter, it's a very important accessory if we want to make sure that everything is working properly. So it's costly to transport, refine, and store gas. You can't cut those costs. Yes, natural gas does contribute to the greenhouse gases effect if it is burned under inappropriate conditions, which is inevitable in many locations around the world. So even though it is more friendly environmentally than the other fossil fuels, natural gas still pollutes the environment. And the last negative I'd like to mention is that it has a long processing process. Before you can use gas commercially or in residential areas, we have this very long, costly process, because first it's mixed with crude oil, and from that we can extract the byproducts such as propane, ethane, and butane. And the extracted byproducts can be used elsewhere. So we see that natural gas in almost its final form can be used in everyday life. However, this is preceded by another important last step, because as we know that natural gas is colorless and odorless, and although it's not non-toxic, it's extremely flammable. So I know that in the UK that the gas has an odor added to it, so that accidents, it's a scent that is added to avoid accidents. So people, if they leave their gas stove on, they can smell the gas and know that something's happening. If there's a gas leak in the street, people can smell the gas and call the company to come and fix that gas leak. And this process, it raises the complexity and the cost of the natural gas production. Over to you, Cleveland.
Paul, I wanted to say that even though, as you said, natural gas is relatively inexpensive in relation to other resources, just imagine LNG in the United States as is exported, very cheap in the Gulf Coast, and the transportation costs are $3-4 in relation to the less than $2 cost of the natural gas in Texas. So it shows how difficult it is, because the cost of compressing and transporting and so on is almost twice as much as the cost of the resource itself. So it has to have, on the other hand, a very compelling argument, because even so, it is an energy resource that can be transported all the way to Japan, China, and Europe, and so on. So, given that difficulty is there in terms of cost, it's still overcome. Less expensive.
SRB is a frequent in the audience, is a very friend of us. So his comments normally is very strong, very direct comments. He's saying that natural gas is less expensive than other hydrocarbons. I trust it means pipeline and gas, not LNG. Yeah, that's right.
Yeah, but I mentioned LNG is a thing apart, because basically it exists just so that the natural gas market can be globalized, because otherwise you really wouldn't bother with LNG. Certainly pipelines can handle things and so on. But the fact that that natural gas is still so inexpensive in major production regions like Texas, and so expensive in countries like China and Japan that justify the multiples in price,
But
and still make it less expensive than many other alternatives.
but your comment is before a Nord Stream explosion, because after that price became high.
Yeah, but exactly. I mean, when we say inexpensive, again, I'm just showing that we have to say in what sense, because certainly natural gas is expensive in relation everywhere, in relation to Texas. LNG is expensive in relation to pipeline gas, and
Yeah,
natural gas in general is
no
still
doubt.
relatively inexpensive in relation to oil. But yes, it depends what we're comparing things to.
Yeah.
Yeah.
Paul, what's your thoughts about this? Serbia are asking for both opinions.
To be honest, I'm not quite sure. I mean, LNG plants are horrifically expensive. When you start talking about the cost per train in an LNG plant, you're talking big dollars. So the LNG plants, they have to be strategically located to feed the market. I mean, Shell had the Prelude floating LNG plant. That was an incredible piece of engineering. Politically, it was quite a smart move because it's not tied to any single country, that plant can be sequestered by a government, and the total investment made by the company would be lost.
Okay.
That's about as far as I can take it.
But Paul, in another view, floating LNG has really been a major change in paradigm in relation to stranded resources and so on, even countries whose gas production would otherwise not be monetizable. There's pros and cons even in how that gas is converted into LNG.
And Cleveland, you could oh, sorry about that.
Yeah, if you can put that.
Your part of natural gas.
Again, let me tack on to natural gas. I consider as the greatest single weapon against greenhouse gas emissions and to fight climate change. If you're really serious about fighting climate change and so on, and you're considering effective solutions, and you're not demonizing all hydrocarbons just because they've got H and they've got C in the composition. So I think we have to be realistic. And in fact, if we were to convert over time, nothing gets done in a year or 2 or 5, if we were to convert many of the world's coal plants to natural gas, we would almost achieve all climate targets within 5 or 10 years. Obviously, that's not going to happen, but that shows the potential reductions in emissions, the bad things that they say about coal and hydrocarbons. Well, natural gas can actually be a very powerful, positive effect. Unfortunately, people don't look at it like that, and we've seen a very negative view of natural gas being treated in the media overall. And I suggest that this has to do with lack of information about what natural gas is and can do. As Paul said, yes, there's problems and challenges in processing, converting it into LNG or transporting it. But the fact that it can be such a powerful force in something which is the energy transition that everybody's so concerned about, that it is a major point that I think is being missed. On the other hand, of course, it can be a major villain, and it is. Nowadays that we have satellite coverage of natural gas accumulations and seeps in the atmosphere from ground sources, we see mega sources of flaring in Russia, Iraq, Iran, Algeria, Venezuela, U.S., Mexico, Libya. Those countries together, more than 3/4 of total flaring in the world. And the amounts are just incredible. That flared gas, which is just burnt, useless, it would be enough to power one of the major countries in the world. It's just an incredible waste of resources. So don't even have to worry about, oh, that's an environmentally harmful way of letting emissions out. Well, it's certainly better than letting methane out, but it's so harmful. Yes, but the waste in energy resources is incredible. And if for no other reason, we should be respectful of that value. But in any case, that is just, one of the negatives, because besides flaring, we also have leaks from installations which are not flared. They just leak methane into the atmosphere because no one is there burning the gas that leaks from a valve or from a tank or from a pipeline. Yet that in many installations and across thousands and millions of places where gas is used is very significant, and there's much research being conducted right now.
Including inside homes.
Exactly, including at the end users. I know, for example, we use gas for the stove and so on. If I smell gas, there's gas leaking. When you turn it on, when you turn it off, when you change tanks and so on, multiply that by the millions of users in the world that are doing that. It's an enormous amount of methane really that's going out into the atmosphere. Yeah. And then there's also venting from operations. Venting is, again, not burned, is direct methane going out into the atmosphere. And that's bad because there's many operations which are not very careful, pipeline operations and so on. And we have to understand that venting happens by natural processes as well. Just look at Siberia. One of the major craters there is venting enough methane to supply several big cities in the world. One point location. And this is methane vented, not burned. And they couldn't even burn it because it's such a big source. So we have to consider scale, and we have to consider the fact that these things will take very long time to correct themselves, even if we're aware that flaring is something we have to control. Many countries have already reduced that. Even Nigeria, which used to be one of the worst offenders, has improved from horrible level to just a very bad level. Russia hasn't improved. It hasn't gone too bad either. But there's many points to consider there.
Yeah, it's a negative point, really is. Paul, your comments on this point?
I don't really have any comments because Cleveland has more or less said them all. But I did have one thing to say, and that was about the flaring. Some countries, it's tolerated. Is that because their HSE or their environmental awareness isn't as strong as other countries? Or is it simply a cost solution?
Paul, when you look at some of these operations, I visited some of the worst in the world, even in Bolivia, which is a gas country. It's just a question of not having the human talent, the human resources trained, and operations being followed at standards that we consider normal. Then in many of those countries, just are unknown, not followed. And so I can't say it has something to do with cost. They don't spend money on that. But the ignorance or the level of lack of norms is something that will take almost a generation to cover, because ESG is making inroads in a lot of NOCs, for example, that are main villains because they don't care and they didn't want to put money into it. But it's a very slow process. And until we see that really advance, I know Petrobras, which we consider an NOC, is very advanced in that. And it's one of the best operated companies in terms of emissions and so on. But when you look at other NOCs in Africa and in Asia, they're just
not the same.
Yeah, but there's also a reluctance by those countries to take Western opinion and experience and learning because they don't like being interfered with, and they just say, "You used to do it in the past. Now you're dictating to us."
Yes, but they're missing out on value. Just the value of vented and flared gas is enough to drive, entire cities in countries that have such energy poverty that
Different
people
countries,
use
yes.
wood and don't even have access to gas.
Yeah, but in those countries, they could be sitting on hundreds of TCF of gas,
Yes,
and they
exactly.
don't care.
Sad.
And
Well, I think we covered a lot, right?
And we need to remember that oil is not used for electricity, only coal and natural gas in this case of our three elements today. Okay?
Well, yeah. One case is, for example, derivatives, diesel and fuel oil.
But a few times is not
Exactly.
common.
Not common. Unfortunately, where that is occurring is because isolated regions. We have some in Brazil, for example, up in the Amazon region, which are not connected to the electric
No,
grid.
that's true.
There's no alternative. But in fact, as
mostly of the case, oil is used for
not
petrochemical products
Yeah.
and for logistics, special logistics with gasoline,
That's the
diesel,
point.
and so on. Yeah.
Very different characteristic for all these three
exactly.
hydrocarbons.
I suppose we covered everything about coal, natural gas, and oil today in terms of positive and negative points. Do you agree, both?
Yeah, mostly.
We've covered a lot, not everything, but I think we've covered a lot.
I didn't touch on a lot of social things, but that's just another dimension.
And we received a lot of comments from Luis Sergio and SRB. So these comments are in LinkedIn. Please, if you can access
We'll look
them,
at it and respond. But we look forward to touching base on other energy resources. Maybe we can do that next time.
Yeah, okay. And next Tuesday, if you both agree, we can go to this other sectors. Thank you so much, Paul Taylor. Thank you so much, Cleveland Jones. It was a pleasure
Nice
for
to
me.
be with you again. Bye-bye.
Thank you. Bye-bye.